Okay, so in the last video we found all the slopes of all these lines, which is all the worksheet asked us to do. But in this one we're going to find the entire equation that describes the line. So to find the equation of a line we need both the slope and the y-intercept. And the y-intercept is exactly what it says. It's where it intercepts the y-axis, where it crosses the y-axis. So we take a look, and this guy, here's your y-axis there, our line crosses it right there. So the y value there is 0, and we call that y-intercept b, just because we can't call it y, because y is going to be used to describe the other points on the line. So we say b is 0 in this case. And so our equation is just y equals 1/2 x plus 0, mx plus b. And since we normally don't write the 0, just y equals 1/2 x will describe every single point on this line. So for example, if I wanted to know, when the x value is 4, what's that y value? Well, when x is 4, the y should equal 1/2 times 4, which equals 2. So I should have the point x is 4, y is 2 on my graph, and indeed I do. So this equation will generate every single point on that line, and it perfectly describes that line. So now we're just going to go through and just doing it is very easy. We got the slope from our last video, so if you don't know how to do that, go look there. And our y-intercepts we can just grab. It intercepts the y-axis, the line and the y-axis meet there at -3. So the b is -3. So y equals mx plus 3. So plus a -3 is just -3. We tend to not write that 1, so that looks just fine. Let's do it again. So our y-intercept is here. Since it's pretty nice and even, I can guess that that b is 1, 2, 3.5, so -3.5. So y equals mx plus b, so plus a negative, just minus that, and that equation will describe that line. Let's do it again. Here our y-intercept is -1, so our b is -1. So y equals -5 x minus 1, so that's mx plus b. Check. We do it again. So this one it feels different, but it's no different. The b is -1, that's where it crosses. So the b is -1. So y equals mx plus b, and 0 times x is just 0. So y equals -1 is the equation of this line. And that makes a ton of sense, because if you look at any ordered pair on this line, the y value is a -1, right? If you named that point right there, that's 1, 2, 3, 4 on the x and -1 on the y. If you named this point here, that's 1 on the x and -1 on the y. If you named this point here, that's -4 on the x and -1 on the y. So notice that every single y value has to be -1. So that's a beautiful way of describing this line, is that it contains all the points whose y values are -1. Check. We do it again. So this one we can't quite see where it's going to cross. The y-intercept is somewhere up here. We can keep extending our slope. Maybe we'll cross it. Let's try. So from this point I'm going to rise up 1, 2, 3, 4, run over 1. And then if I rise up another 1, 2, 3, 4, and run over 1, I will end up right there. So that's at 1, 2, 3, 4, 5, 6, 7, 8, 9. So our b is at 9. So 1, 2, 3, 4, 5, and then 4 more, 6, 7, 8, 9. So now our equation is y equals mx plus b. We can check it real quick. So let's say we want to check, hey, when x is, this point here looks nice, right? That's the point -3. So when x is -3, the y would equal 4 times -3 plus 9. so the y should equal negative 12 plus 9. So the y should also equal negative 3. Does the y value equal negative 3 at that point? Yes, it does. Our equation works. Amazing. Let's do it again. So your y-intercept is down there. Your b is 1, 2, 3, 4, 5, so negative 5. So your equation is y equals mx plus b. Check. We do it again. So here m is undefined. So when you go to write y equals m, you're like, yeah, I can't do that. But it has a similar feel to the one we did with the horizontal. Our horizontal was y equals negative 1. Check out this one. Every single x value here is, in this case, it's 0. So this point here is the point 0, negative 4, right? That point there is the point 0, negative 1. Let's say that point there is the point 0, 3. So every single point on this line has an x value of 0. So these vertical lines, instead of having a typical y equals mx plus b, they end up being x equals. They're kind of funky because their slope is undefined. But as soon as you start looking at those points, you're like, dude, that makes sense. That's how I'm going to describe that line. The x value always equals 0. We keep going. So here, my y-intercept, 1, 2, 3, 4. So b is 4. So y equals 8/3 x plus 4. Check. And again. Right in the middle there. Let's see. So it's not perfect in the middle like it was in our last one. This one we're going to have to do a bit more work. So let me show you. So normally you have y equals mx plus b, and we don't know what the b is. Bummer. But we do know that it should be that m is negative 3/2. Now any single point on this line should make it true, so I'm going to pick my favorite point, plug it in, and figure out what b is. So I'm looking at, let's see, looking at maybe this point here. So that point is 1, 2, 3 on the x and 1, 2, 3, 4 on the y. 3 on the x, negative 4 on the y. And I could have chosen any point, but I didn't want to choose that one because I just wanted to make the points distinct. But you could do it with this one, you'll get the same answer. So this is the x value, this is the y value. So the y is negative 4, and that should equal negative 3/2 times 3 plus b. So now we just solve this. So a negative 4 should equal negative 9/2 plus b. So negative 4, negative 9/2, I'm going to change it to negative 4.5 plus b, so that when I add the 4 over, it does become negative 4 plus 4/2 is a half. So b is a half, which is what you might have expected, but I just wanted to be sure. So b is a half, and so now we can write our equation. Y equals mx plus b. Oops, sorry, that got all over the place. So y equals negative 3/2 x plus a half. Check. All right, next one should be better. Oh no, again. So again, that point is not easy to read. So I'm going to do, I know it's supposed to be y equals 4/3 x plus b, but I don't know b. So I'm going to choose my favorite point. I'm going to choose maybe that one there. So 1, 2, 3, 4, 1, 2, 3. So 4, 3. So the y should equal 3. That's, the x is 4, the y is 3. So the y should be 3 when the x is 4. So 3 should equal 16/3 plus b. So 3 should equal 5 1/3 plus b. If I subtract 5 1/3 from both sides, I get negative 2 1/3 is b. And that does look about right. Negative 1, 2, and a little bit more. So now I can write the equation of this as y equals mx plus b. And we have that. Let's keep going. Finally, a nice one. There we go. So the b is just 1. So y equals mx plus b. Check. Cross your fingers. Another nice one. The b is just -1. So y equals mx plus b. We don't tend to write 0 times x because 0 times x is just 0. So 0 minus 1 is just -1. So y equals -1. And again, thank you. So the b is -2. So y equals mx plus b. Check. Again, when it's undefined, we can't do y equals m. Aw, man. So we do x equals instead. What does the x equal? X is -3. For every single point on this line, test it, the x will be -3. Check. Let's do it again. Aw, man, another hard point to read there. So we're going to have to do our trick where we take a point on our line that we can see. So I'm going to, so -1, 4. So I know that y is supposed to equal mx plus b, but I don't know the b. So I'm going to plug in this. So when x is -1, the y should be 4. So the y should equal 4 when the x is -1. And so 4 should equal +8/5 plus b. Maybe this time I will change the 4 and get a common denominator. 4 is the same as 20/5. 20 divided by 5 is 4. Just grabbing a common denominator. So when I subtract 8/5 from both sides, I'll get 12/5 is b. And just to make sure that makes sense, that's 2 and 2/5 for the b, and that's 1, 2, and a little bit more. That makes sense. So our equation is going to be y equals mx plus b. And I can leave it as 2 and 2/5, or I could put the 12/5 there. And there we go. Check. And that is all.